Before we do problems 12 through 16, I wanted to make sure we talked about how to find the domain. We'll talk about it first and then we'll do an example. There's two things. This mapping diagram is, I've been staring at it here for a few moments, and this doesn't really do it for me. If it does it for you, great. You can look at it, pause the video, and try to analyze it. But the bottom line is this. If you look at the expression f of g of x, then the first thing when you're working from inside out, you have to figure out what x values are first acceptable to replace or for inputs into the g function. So here, being the domain of g, okay, there's all these values, okay. So there's no way that if the value x is not in the domain of g, could it be in the domain of f of g of x, if that makes sense, okay. So the first thing you're going to do here is determine, number one, down here, this is where you want to kind of camp out, I think. G of x must be defined so that any x not in the domain of g must be excluded. So the first thing you're going to do is you're going to look, are there any restrictions on x when I try to put them into g? Okay, so that's the first thing you're going to look for. Okay, then once you do that, then you replace, then you figure out what g of x is, and you use that as your input for f, and then once you find f of g of x, then you have to eliminate any more x's that would not be in the domain of that resulting function f of g of x. So there's two steps to these, and it's easy to remember because we have 1, 2 functions. If we had 3 functions, there'd be 3 steps, okay? So keep that in mind, and we'll work through these examples, and I'll try to illustrate that, okay? For the first example, again, we're just coming up with the domain of the composite function, f of g. So the domain of g, let's do that first. Domain of g is all real numbers. Okay, so now this is easy when the domain is all real numbers because we don't have any restrictions on the g of x function. Okay, so then we replace, when we find f of g of x, then we just replace like we did before. F of g of x is 6 times g of x, which is x plus 3, okay, plus 36. Now you should quickly recognize that we have you don't need to actually do all the rest of this stuff if you don't want to, but when you simplify f of g of x, you can see that it's a linear function, which is a polynomial function, and so therefore the domain of, therefore the domain of f of g of x is all real numbers. Okay, so we've shown f of g of x. We don't have any restrictions on g of x. That's key. You can't have a domain of all real numbers here if you have any restrictions on g of x here. Understand? Good. Alright, so let's try this one. f of g of x. Domain of g of x is all real numbers. So f g of x, then we don't have to worry about g of x anymore. We don't have to remember to take anything out at the very end. F of g of x then would be 2 over the g of x right there. So again, g of x is our input for f of x, and we have an x plus 10 plus 1. So that ends up to be 2 over x plus 11. Okay, well this is f of g of x. Well, we can clearly see that our restrictions is that x, such that x cannot be equal to negative 11, because x plus 11 equaling 0, we solve that, we get negative 11, and we know from our exhaustive study of polynomial and rational functions that we can't divide by a negative number. We can't divide by 0. I don't know why I said that. And so therefore, this guy right here is our domain of f of g of x. Okay? X cannot be negative 11. If you are feeling brave, go ahead and pause the video and try number 14. Okay. But the domain of G, here I'm going to go ahead and get started. Domain of G, we can see that x cannot be equal to 0. So that's going to be something we highlight. We've got to remember that x cannot be equal to 0, because you're going to see what happens when we get down to the very end. Well, again, f of g of x is equal to -1 over our g of x, which is -80 over x minus 8. Okay, you don't have to simplify this entire fraction now. All you have to worry about is setting this guy right here equal to 0. When you set that equal to 0, you find any other restrictions that might be placed on the real numbers that we want to use for our composite function f of g of x. We already know that we can't put 0 in, okay? But there may be something else here that comes up when we try to set this equal to 0. So we get -80 over x minus 8 is equal to 0, and I purposely put the 8 up there because I know what I have to do here. I have to get a common denominator, and that's multiply top and bottom by x. Okay? And so we get -80 minus 8x all over x is equal to 0. And we got kind of lucky here, because if by chance, no, we didn't. We didn't get lucky. We still have to understand that x can't be 0. Well, x can't be 0 here anyway. But to make a fraction equal to 0, from remember our study of rational functions, if we set the numerator equal to 0, the function, this fraction would be equal to 0. So when we set the numerator equal to 0, we have to solve for x. We're going to add 80 to both sides. And we get -8x equals 80. And then when we divide top and bottom, left and right by -8, we get x is equal to -10. So the bottom line is that the domain then is all real numbers x, such that x does not equal 0 or -10. So when you have a highlighter that stands out, you can see the domain of g of x, we eliminated 0, and the domain of f of g of x, then we had to eliminate -10, because -10 would make f of g of x equal not exist, and 0 would make g of x not exist. In fact, 0 would also make f of g of x not exist as well, but we don't always get that lucky. So sometimes that initial restriction on the domain of g kind of vanishes when we get into f of g, and you might see that here in number 15. So I'm going to go ahead and keep going. If you were brave and got number 14 right, great. Maybe you've tried number 15 as well, and if you haven't, then please do. Okay, so domain restriction here, x cannot be equal to 8. Domain restriction of g of x. Okay, so I'll highlight that, and if we find any other restrictions, we'll have to highlight those as well. So f of g of x is equal to the square root of 3 over x minus 8, right? So 3 over x minus 8 is g of x, goes there, minus 3. Okay, so we've got a lot of work to do here. 3 over x minus 8 minus 3 has to be greater than or equal to 0. Okay, leave a lot of room, my apologies. Then if we get a common denominator, we multiply top and bottom of this 3 over 1 by x minus 8. Okay, still greater than or equal to 0. And maybe we'll just save number 16 for later. Yeah, we'll just save number 16 for later. Let's just do all the work here. Okay, then we get 3, I'm going to bring it down here, 3 minus 3 times x minus 8 all over x minus 8 has to be greater than or equal to 0. We get 3 minus 3x plus 24 over x minus 8. Okay, and then 3 plus 24, that gives us 27, so we have 27 minus 3x all over x minus 8. And if we factor out a 3, we get 9 minus x over x minus 8 greater than or equal to 0. Well, guess what? You're supposed to know now that you build a sign chart to determine this, and we have x equaling 8. Oops, let's put 8 here because we're going to have x equaling 9 as well. So 9 is what makes the numerator equal to 0, so that's a good value, but the 8, we already took that out, that is D and E. Okay? And so in between, or to the left of 8, let's say we pick x equals 0, we see that we have 9 minus 0, so positive numerator, 0 minus 8, negative. So those are bad values in between, or on the interval from negative infinity to 8. Between 8 and 9, 8.5 test value, we can see 9 minus 8.5 is positive, and 8.5 minus 8 is positive. So that's good. And then once we get past 9, we could clearly see 9 minus any bigger number than that would be negative over a positive. So on the interval from 9 to infinity, what's under the radical is negative. And so finally we see that the interval from 8 to 9, not including 8, but including 9, would be our domain of f of g of x, because we already eliminated 8 anyway, and I'm kind of hoping for an example in which that domain restriction on g got eliminated. But all real numbers then between 8 and 9, not including 8 but including 9, would be the domain of the function f of g of x for number 15. And that's it. You've got a few multiple choice problems to do on the Google form. And then, was there something else in the Google form? No, I think that's it. Oh, there is something else. Make sure you also fill out on the Google form some feedback on the lesson and any questions that you still might have. We'll see you in class.